So this is my spring PDI topic plan. As you can see, my planning and preparation component of focus is engaging all students in learning. And basically, I was really upset when I found out the timing of this because we are actually doing our unit on inverses right now, and inverses are not a state standard anymore in math, so I don't really know why we're teaching them, but all schools still teach them, so I guess we'll just follow everyone else and teach inverses. I guess the one good thing about teaching inverses is it does allow us to teach to this 8th grade standard here, which is justify steps in generating equivalent expressions by identifying the properties used, including the properties of algebra. Now, these properties of algebra are ones that you guys probably remember. They are the associative property, the commutative property, and the distributive property. Also, we want to make sure that they know their order of operations and how to use grouping symbols. So a lot of the examples that we're going to be doing do have parentheses, and then ones that we do later even will include some absolute value symbols as well. So, unfortunately, the activity that I wrote my PDI goal plan about is not an activity that I can do with this unit, just because of the way that our school teaches this unit. So I was a little bummed, but I thought of something else to try, so we're going to try this, and if you guys have any feedback, I would greatly appreciate it. Basically, what we do in our school is we teach table form in Algebra 1. Algebra 1 is a course for 6th and 7th graders. It's the normal 7th graders and the advanced 6th graders, but most of the standards that we do are the 8th grade standards because they're a year ahead, I guess. Because part of our charter for our charter school, Math and Science Academy is a charter school, is that all students must take and pass a calculus course before they can graduate from MSA. So we do push them rather quickly through math. The other good thing about our school, though, is that we don't allow kids to move on unless they have at least a C- if they're at grade level in their math class, or a B- if they're advanced in their math class. So that's kind of nice as well. Anyway, back to my topic plan. The students have just learned the concept of inverses. They've learned how to work backwards to find, especially numbers, but they're working on how to find inverse functions based on just the thought process of, for example, I'm adding 4 and then dividing by 2. If I do that backward, I would need to first then multiply by 2 and then subtract 4, or something like that. But we haven't actually done the algebraic method of solving, where we would actually take x and y and switch them in our original function and then solve for y, as most of us learned back in late middle school or early high school. So we're going to teach them how to do that, finding the inverses algebraically through a 2-column proof. We also at MSA do not offer a geometry class, so we need to make sure that we hit the 2-column proof standards as well as the justification standards and their logical reasoning. The cool thing about this is it actually leads into my rationale for this lesson, which it's important for students to be able to reason through their work, even if it is not a math proof. Many times, when people come across obstacles in the workplace, or even anywhere in life for that matter, it is important to be able to reason through the steps you are taking to come to your solution. So I want to make sure to emphasize that as we're going through this. But students will have had one assignment working on table form that was briefly introduced the day before, and then this day we're really going to explore it and make sure that they're understanding it. So I had an example of what I'm going to do here. Obviously, this equation is not a function. We aren't going to find the inverse, but I'm going to show you how table form works. Basically, what I plan to do is give students within their groups a large piece of poster board and then a bunch of paper strips. Notice these equations over here and justification steps. There's 8 of them there. 1, 2, 3, 4, 5, 6, 7, 8, because there's 4 things for mine. With theirs, there'll be probably 12 to 16, depending on their initial function and the check step that is associated with it. But I will give them each of these type of things on a different paper strip, and I will want them to organize it on a table that looks something like this on their poster board, and then I'll actually give them glue sticks to glue it on. Now, the cool thing about this is I hope it will get students talking, and it will also get them using the terminology that I want them using, especially in this justification column. Sorry about that. Justification column. And they'll be able to work with their groups in organizing that and setting it up and then I will actually expect them to present later in that day, so maybe after 15 or so minutes of working with their groups. I will want them to present to their group, present to the rest of the class what they found, how they went about doing it, how one may go about doing it if they didn't have all of these things already written out for them, anything like that. So, an example here of what someone would do is they would say, okay, well, I know I need to start with an original equation. So my original equation is going to be my justification, but which one of these with the variables and numbers looks like an original equation? Well, it must be this one, because that has nothing going on in it. W plus 4 equals 6. And I assume you're going to solve for W. So the next thing that you need to do for solving for W would be that we need to subtract 4 from both sides. Well, which of these steps over here shows that? It's this one. We're subtracting 4 from both sides. Then, what property we're actually using is the subtraction property of equality. Once we subtract 4 from both sides, we'll get that W equals 2. How we got that was because 4 minus 4 equals 0 on the left-hand side, and 6 minus 4 equals 2 on the right-hand side. Finally, we'll have our check step, where we plug 2 back in for our variable of W, and we get 2 plus 4 equals 6, which shows us that 6 plus 6 is true, which is check. We checked it. So that's how I'll expect students to do it. Again, obviously this is an easier table. I just wanted to introduce what table form was, and it would be a little harder for them to figure out when moving through, and I think it will provide great discussion among our class. It'll also prove as a homework check for students. Not so much as a homework check for me to check their homework. I'll be able to do that as they're working on this, but more so a homework check for students to check their own work against these answers, because each group will be given a problem from the previous night's homework that students were given to explore table form and really try it for the first time on their own. So they'll be able to check all their answers. For students who need a longer time to process, I'll take pictures of the posters and post them on my website. Students that are advanced, unfortunately, I don't have much I can do, because originally I thought I could maybe take out some of the justification steps or some of the algebraic steps and have them actually write them in themselves. However, I want to make sure that everyone's on the same page when we're first learning table form, so I think I'm going to still provide them all those. I think what I will do, though, is split up the struggling and advanced students so that they can really work together, and the advanced students can help the struggling students can benefit from working with the advanced students, and overall, I think it will provide more time just in general, because I'll be able to float around a lot more than having to work with select students if they're split up with the advanced students. Thanks for listening to my topic point, and I look forward to videotaping it and sharing it with you all.